Now we turn to measures of spread, numbers that tell us how much variability there is in our data. Consider air pollution measurements at 2 sites. Both sites have a mean of 36 micrograms per cubic meter, but look at how the data points spread out. Site 1 has values ranging from 24 all the way to 68, while Site 2 clusters tightly between 32 and 40. We would miss the dangerous high pollution days at Site 1 if we relied only on the mean. The simplest measure of spread is the range, which is the maximum minus the minimum. Site 1 has a range of 68 minus 24, which equals 44. Site 2 has a range of only 8, but the range uses just 2 values, so it is very sensitive to outliers. The standard deviation is built on the idea of deviations. A deviation is how far each value is from the mean. The value 33 has a deviation of 33 minus 36, which is -3. The value 40 has a deviation of +4. Notice, deviations left of the mean are negative and right of the mean are positive. We cannot simply average the deviations because they always sum to 0. Instead, we square each deviation to get the sum of squares, or SS. We then divide SS by n-1 to get the sample variance, S squared. Taking the square root gives us the sample standard deviation, S. Let's calculate the standard deviation for Site 2. The mean is 36. For each observation, we find the deviation and then square it. 32 minus 36 is -4, squared gives 16. We do this for all 8 values. The deviations always sum to 0, confirming our work. The sum of squares is 58. Dividing by n-1, which is 7, gives a variance of 8.29. Taking the square root, the standard deviation is about 2.88. Now we can compare. Site 1 has a standard deviation of about 15.6, while Site 2 has just 2.88. This confirms what we saw visually. Site 1 pollution varies widely, with some dangerously high readings. In summary, the range is the simplest spread measure, but only uses 2 values. Deviations measure how far each value is from the mean. We square and average those deviations to get the variance, and take the square root for the standard deviation. A larger standard deviation means more variability.